Okay, welcome to the second video of today. If you started this video, that means you have finished column 1, column 3, and all 20 questions on the back. And in addition to finishing all that, I have checked it off. You haven't moved on without me checking all of that off. So now you're moving on. We're done, not done, but like moving from electron configuration to something new. So let me erase all of this. Told you, man, erasing is the best. It is so much fun. Erase, 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 erase. Okay. It is all erased. Now, we are building on electron configuration with some new things. We're building on it with what are called Lewis dot structures or dot diagrams. So these are Lewis dot structures, also called dot diagrams. Either way, it says on your sheet dot diagrams, but the official scientific awesome name is Lewis dot structures, and then we have dot diagrams. What these deal with are valence electrons. Now, valence electrons is something that we have talked about in class before. If you remember, column or group 1 here has 1 valence electron. Group 2 has 2 valence electrons. And then we skip out over all these for now for valence electrons and go over here to group 13. Group 13 has 3 valence electrons, 4, 5, 6, 7. And then, remember, we moved for we moved helium on our periodic tables over here, so it's with 2 valence electrons. Group 18 has 8 valence electrons, and every single one of these elements on this table want to be like neon, argon, krypton, all these right here. They all want to have 8 valence electrons. They think they are just the coolest people in the world if they have 8 valence electrons. So that's where they're all trying to get. They're trying super hard to get there, and they haven't been able to get there yet. So you need to make sure you mark on your periodic table 1, 2, 3, 4, 5, 6, 7, 8 when referring to valence electrons. Now, what are valence electrons? As a recap, the definition of valence electrons, so it's spelled like this, valence electrons. These are the number of electrons in the outermost shell. So it's the number of electrons in atom's outermost shell. So you know all its inner shells. Before you can move on, you have to fill up this one before you can move to the second one. Fill up the second one before you can move to the third one. So the valence electrons are however many electrons it has in its last shell. And these ones are so cool and so awesome that they have 8 valence electrons in their outer shell because they are the coolest elements in the entire periodic table. So like if I was an element, I would be a noble gas because I'm pretty legit. So I would be probably argon. That sounds kind of cool. These would have 8 valence electrons, 7, etc. So number of valence electrons, we're going to do this progressively. So you can pause the video and you can fill in the column that says number of valence electrons with each of these elements. Oxygen, for example, would have 1, 2, 3, 4, 5, 6 valence electrons. So you would put 6 because it's right here in this column, column 16, group 16. What's our next one there? Sodium. Sodium would have 1 valence electron. So you're just counting these groups. That's very straightforward. That's why I'm not going to do a lot of examples. So go ahead and fill it. Pause the video right now. Pause. Okay, coming back. You should have paused the video and you should have filled in the number of valence electrons. So you should have that column completely full because you have to do that before you can do our dot diagram. Our dot diagrams, these are also very straightforward. This is just based on, it's a diagram, and it's a way to show everybody how many electrons, how many valence electrons an element has using a little diagram. So we are going to use the example of phosphorus. Phosphorus is right here. So phosphorus. And this again is a Lewis dot structure or a dot diagram. Now with phosphorus, the first thing you have to do when doing a dot diagram, wherever that is on here, dot diagram, is know how many valence electrons it has. So how many valence electrons does phosphorus have? Let's find out. 1, 2, 3, 4, 5. It's got 5 valence electrons. Therefore, so I'll put that over here. It's got 5 valence electrons. Therefore, we are going to put 5 dots to represent these electrons around the symbol P. Now, where did I get P from? P is the symbol for phosphorus. It has 5 valence electrons. So how I'm going to fill out my Lewis dot diagram? I'm going to put 1 electron right here. You always start on the right side of the symbol. 1 electron here. Then you go to the left side. 1 electron right here. Then you go above. 1 electron right here. Then you go below. And if you have more than 4, you go in the same order again. You go back starting with the right once again. So this right here is a very poorly drawn version of the Lewis dot structure of phosphorus. How did we get here? First, I looked at my element, P. I put my element symbol, P. Then I found out how many valence electrons I had, which for phosphorus is 5, because it's in 1, 2, 3, 4, 5. The 5th group that we count, because remember we skip all these. So it's got 5. So then I put my dots on here, and I put them in this order. Start on the right. I go 1, 2, 3, 4, and 5. Go back to there. And this is my Lewis dot structure. So what this is representing, when you see this, it's representing the element P. So you'd go, oh, P, phosphorus. Okay. And then the number of valence electrons it has. Again, valence electrons are in the outermost shell. It's got 1, 2, 3, 4, 5. Look at that. It's like magic. All right. One more example of a Lewis dot structure, so then we will move on. Let's do nitrogen. So I look at my symbol first. It is N, nitrogen, 1, 2, 3, 4, 5. No, it's got 5, so I'd go 1, 2, oh, sorry, you should have gone here first. 1, 2, 3, 4, and then 5, just like that. This is going to be beneficial later on when we bond elements together because it'll show how their electrons bond, but for now, all you're doing is putting the number of electrons around a symbol. So what I want you to do is I want you to try chlorine and try carbon. Try those two. Pause the video, try chlorine and carbon. Okay, you should have paused the video. Chlorine, see it here. It's going to have 7 valence electrons, so I'd go 1, 2, 3, 4, 5, 6, 7. See how I went in the same order on my second round? I went 1 here, 2 here, 3 here, 4 here, 5 here, 6 here, 7 here. So I end up with this almost totally full. Then we have carbon. Carbon, we're going to have 1, 2, 3, 4 valence electrons. So I'd write carbon, and I'd go 1, 2, 3, 4. And those are our Lewis dot structures. Make sure I check those off, and you can try to finish your Lewis dot structure column right here. Ask questions as they come. I'm trying to go a little bit faster today so the videos aren't as long. But Lewis dot structures, which is in column 2, dot diagram, do your dot diagrams for each of these elements. Have me check it off before you're done. Pause the video, do those. There's one more thing we got to cover. Pause the video, do those. Have me check it off. Ask a neighbor if you don't know. Okay, you should have done your Lewis dot structures, meaning you should only have 2 empty columns left right here. I say number of electrons lost or gained and charge on an ion. All that's referring to is how many electrons an element has to gain or lose to become a noble gas. Remember, they all want to become noble gases. Again, that's a terrible circle. So like fluorine, it has 9 electrons, right? So if you drew the Lewis dot structure, it'd be like this, F, and then it's going to have 1, 2, 3, 4, 5, 6, 7. Sorry, I said 9 a second ago. I'm referring to valence electrons right now. So it's going to have 7 valence electrons. So it'd be 1, 2, 3, 4, 5, 6, 7. 7 total, right? If fluorine could have its way, it would add 1 right there, and it would be perfect. Every element wants a Lewis dot structure to look like this, with 2 on each side, because it's nice and symmetrical, and people like symmetry. So everybody wants a Lewis dot structure like this, 2, 2, and 2. In order to get this, fluorine has to add 1 electron. Remember, we added that 1 right there. So fluorine would have to add 1 electron to get this Lewis dot structure. So number of electrons lost or gained, if we were doing fluorine, we'd say 1 electron gained in order to get 8. And you can use your Lewis dot structures. It'll help with that. Let's look at oxygen. That's your first example you have on there. Oxygen, you should have drawn its Lewis dot structure. It's got 6. 5, 6. It should look like this. It's got 6 valence electrons. How many does it need to get 2, 2, 2, and 2 to make it symmetrical? How many more electrons does it need? You look at the Lewis dot structure, you see it needs 1, 2. And then we're all symmetrical. That's a benefit of the Lewis dot structure. You can see how that works. So we would go electrons gained, you would put 2. And of course, this goes back to the last unit. The last one says charge on the ion. If you gain electrons, you're going to have a negative charge. Remember that. So if oxygen gained 2 electrons, its charge would be -2. So the charge of oxygen in this situation would be -2 because it gained 2 electrons. If we gained 3 electrons, it'd be -3. We did that last unit. You know that. You know that. If it gains electrons, it's got a negative charge. If it loses electrons, it's got a positive charge. Let's do one example where it loses electrons. Let's do Na. That's your second one. I'm doing you a lot of favors here. Na. Okay, so it wants 8 all around, right? Right now, it's only got 1. It's super sad because it's in column 1, so it's only got 1 valence electron. So is it going to try to gain 7 electrons? No, it's not going to gain 7 electrons. Crazy. It's just going to get rid of 1. And this was on the test. When you get rid of 1 valence electron, sorry about that. My bad. The issues with live TV, am I right? Even though this isn't live, but don't worry about that. Okay, it would just get rid of 1 electron. When it gets rid of 1, remember from the test, that eliminates a whole energy level, so suddenly it becomes just like neon. If sodium loses 1 electron, it becomes just like neon, and it'll end up with a full energy level because it got rid of that 1, and so it has 8 left over. See that? It's like magic again. Go team, go. Okay. Last thing, I'm just going to have you add to your notes, and then I want you to practice on charge on these last 2 columns, and have me check as you go along and have your neighbors check. I just want you to label if you have room on your periodic table. These right here, all of these will always end up with positive charges on their ions because they will always lose electrons. And all of these over here, oh sorry, these are included. This row will also end up positively charged ions, whereas all of these 3 columns, these will all end up negatively charged because these gain electrons, these 3 columns from nitrogen to fluorine, gain electrons to become like our noble gases, because remember that's our goal. These will lose electrons because it's easier for them to lose electrons to be like our noble gases. But we've been over ions, so hopefully you have a general gist of this. By the end of today, this whole thing is done, and this whole thing is done. Practice makes perfect. We got a lab coming up we got to be ready for, so hopefully you're ready. This is the end of the video for today. 2 videos, 1 day, epic chemistry class. I'm out.